Hi, I'm John Ray Refereza, a BS Physics student at the University of the Philippines, Baguio. So my thesis is titled Flood Risk Prediction and Early Warning Using LSTM Networks Augmented with Time-Gun-Generated Synthetic Data for Improved Community Response in Libon, Albay. So it's a bit mouthful, but basically it's about using deep learning to predict floods 24 hours in advance for a specific municipality in Albay. So my thesis is about building a flood prediction system for Libon, Albay, specifically for 6 barangays in Libon, which are Olagon, Paklas, Bulusan, Bonbon, Sagrada, and San Agustin. So the problem I'm trying to solve is that Libon is basically the catch basin of the whole province of Albay. So it floods a lot and pretty severely. But the MDRMO, which is the Local Disaster Response Office, has no tool to warn communities ahead of time. So they find out flooding is happening when it's already happening. So what I did was train a deep learning model using 3 years of hourly rainfall and river level data. Use a technique called time gun to generate synthetic flood data because severe floods are really rare in the dataset. And then after that, put the predictions into QGIS map, and that shows which roads will be flooded, how bad, and what hour over the next 24 hours. So honestly, Libon floods a lot, but doesn't have its own early warning system. So most flood forecasting tools in the Philippines are built for large regional scales and don't really capture what's happening at the barangay level. So as a physics student, what drew me to this problem is that at its core, it's about basically understanding cause and effect in a physical system. So how does rainfall upstream translate into road flooding downstream, and how long does it take, and how severe does it get? So I wanted to approach it from the physics angle while using modern machine learning tools to actually make something the community can use. So the most immediate use is for, of course, the Libon MDRMO. So instead of reacting to floods after they happen, they can check a 24-hour animated map that shows which roads are predicted to flood, at what severity, and at what hour. So that gives them enough lead time to deploy rescue teams if necessary early. So issue advisories and coordinate with barangay officials before things get dangerous. And then beyond Libon, the approach I used is replicable. So any municipality with similar monitoring data can adopt this pipeline without needing expensive infrastructure or a big technical team. So definitely the most difficult part while doing this study is the class imbalance problem. So in 3.5 years of hourly data, severe flood events make up less than 0.2% of all records in most barangays. So the model would just learn to predict no flood all the time and still be 99% accurate, which is basically useless for early warning, right? So, and then also standard oversampling methods like smooth don't work well here because flood data is sequential. So the way a flood builds up hour by hour matters. So that's why I use time gun, which is a type of generative model designed specifically for time series data. So getting it to generate realistic flood sequences and validating that if they actually made the model better took a lot of trial and error. So of course, the most fun part is seeing the QGIS map actually work. So after all the data cleaning, model training, and debugging, the moment I loaded the prediction outputs into QGIS and saw the 6 barangay points lighting up in different colors, green, yellow, orange, and red, updating hour by hour across the 24-hour frame animation just felt really satisfying. Yeah. Like this is actually something someone can look at and use. So that was really, again, that was satisfying, and it was cool to see that the spatial pattern of which barangays flag the highest risk match what you'd actually expect from the geography and hydrology of Libon, which is exactly what a physicist would want to see.